Everyone, welcome to today's session. We are going to give people just another minute or so to join us, and we'll get started. Thank you. All right, let's go ahead and get started. Thanks everyone for joining us. We're excited to be here with you this morning or afternoon, depending on where you're located. Wanted to do just a quick intro and a couple of housekeeping items, and then I will pass it over to Jamie, our presenter today. First of all, this webinar will be recorded, so you can look for that recording to be sent to you in a follow-up here in the next couple of days. If you have any questions that come up throughout the webinar, we're excited to answer those for you. If you just go ahead and put those in the Q&A section of Zoom on your browser, then we will do our best to get all of those answered. And then finally, our presenter today is Jamie Reed. He's a senior member of our technical account management team. And at this point, I will kick it over to him.
Thanks, Taylor. I appreciate it. And thank you to all the attendees for giving us an hour of your time and attention today. So good morning and good afternoon, depending on your time zone. Let me share my screen and we'll kick things right off. I'm joining you live from Calgary, Alberta, Canada, and I hope that everyone else is having a great day. I'll also share that Sam and Sean, two of my very talented colleagues, are here to address your Q&A. So send us your spiciest and hardest questions. We're here to really dig deep into those at the end of the presentation. We'll allot maybe 10 or 15 minutes at the conclusion. So as Taylor had mentioned, today we're here to talk about DevSecOps and how GitLab can help you achieve better outcomes through integrating security as part of your workflow. We're really going to touch primarily on two key topics. First and foremost, we're going to take a look at application security testing and how GitLab Secure can help you find and fix your vulnerabilities before they make it into your production deployments. And then we'll have a light touch on how GitLab's policy compliance and auditability can help you meet your compliance needs. I find this pretty intuitive, but I always like to start by reiterating the cost of remediating bugs or vulnerabilities as you get nearer and nearer towards production. So this slide really illustrates how much software bugs and vulns cost the software industry. And with a cost of $300 an hour for a software developer per the 2019 Software Developer Price Guide, we can see here from NIST's study on the impact of inadequate software testing, the cost of remediation and how it dramatically increases the closer you get to production. So while finding a bug or finding a vulnerability and being able to remediate it quickly while you're writing the code means that maybe on average you'd spend about 2.5 hours remediating a finding. By the time you get to production, context switching back to code that you or another person had written previously can quickly balloon. And here you see the cost jumping up to, say, $4,000 for a finding in production. Likewise, this chart here, which we sourced from NIST study, shows that cost of remediation of a vulnerability or bug can be up to 30x at the production stage versus what it is at the requirements or scoping stage. So with that in mind, I wanted to really describe two separate problems for you. Traditional application security tools were built 10 or more years ago, before today's modern software development methodologies like DevOps, with extremely short cycles and regular deployments, were commonplace. As an industry, we need to get beyond the idea of simple shift left and give devs and giving devs maybe some light feedback as part of their IDE. And we want to lead into a new era where security is baked in and part and parcel of the entire software development lifecycle, where a single application, a single interface, and a single data store can be leveraged to help you achieve better software development outcomes. Applications today are the prime target of cyber attacks, and a lack of hygiene can allow exploits to be reused. Compounding this, application security tools can be quite expensive, and they can require integration of both technology and processes. There's a significant operational investment that organizations need to make in order to bring these separate tools into their workflow. In order to shift left, you must include both your developer and your security teams. Both teams need to have close collaboration and agency throughout the entire process. Compounding this is the reality of modern software development. As we all strive to accelerate and shorten our cycle times, code changes are getting faster and faster. More open source technologies are being used, more APIs, and more microservices. Iterative development can be incongruent with full application security scanning and a more waterfall-esque approach. Without scaling through developer enablement, automation, and agency, DevSecOps won't scale. Additionally, next-generation software gives way to new attack surfaces. Deployment to more modern methods like Kubernetes clusters and in public clouds really changes the surface of which bad actors can compromise your applications. Composable software with more open source can mean that traditional approaches to network security become less relevant. And punitively, traditional application security tools are typically usage-based. You pay on a per-scan basis, which means to be more secure, you end up penalized. You have to pay more for it. To give you a bit of a visual here, here's what traditional sort of waterfall-esque application security looks like. As developers commit code to a repository, run CI, and deliver their code to various environments, typically, after code has been delivered to, say, a pre-production or test environment, security teams will pick up testing, and maybe they'll run some static or dynamic scanning against that test environment, analyze the results, and then share those back with developers. That can be a multiple week or even multiple month cycle, and it creates a lot of unpredictability in your release cycles. So what do we do about this? Imagine a world where you could scan all of your code every time, seamlessly in the context that the developers are working within, using fewer tools and including both your development and your security and operations teams all on the same page. And while doing all of this, keep your compliance auditors happy. With GitLab, we can automate all of these tests and include them into every merge request. You no longer have to choose between risk, cost, and agility. Because GitLab is a single application for the entire software development lifecycle, you can use it on every code commit. All of the tests are run automatically and presented in the context in which the developer is working. The GitLab app creates a complete review app so that dynamic testing of your developer's changes can be run on working code as well. All of this gets included very early in the life cycle of a given change. There's no need to buy separate single solution security tools. And if you've already got robust SAST or DAST or other infrastructure scanning tools in place, no worries. You can reduce your costs by using them more sparingly and bringing those results into GitLab and presenting them contextually where developers are working. This slide shows you the 10 different stages that GitLab operates within. And it also highlights some of the available security testing tools that are part and parcel of our ultimate offering, including static application security testing, dynamic, dependency scanning, license compliance, secret detection, and more. The key here is to have development and security working together. Large enterprises that I speak to, they all realize that as a security organization, you can scan and present results ad nauseum until the cows come home. But getting those actioned and showing that burn down chart going in the right direction, that's a much more difficult problem. Modern enterprises today recognize that working very closely with the developers themselves will lead to more predictable outcomes, shorter cycle times, and faster time to remediation. All of these are critical, but this does represent something of a fundamental shift. This way, with GitLab, you can report security vulnerabilities directly to the accountable developer and provide them the agency and knowledge that they need in order to remediate them before they integrate into your mainline code branches. This also benefits security teams. You can do less tracking and spend less time on triage and focus on where you can be the best value add for your enterprise. It also gives you the ability to test every single code change and improve your coverage. Context switching here is really the key that I want to leave folks with. The cognitive load of changing from tool to tool really slows developers down. And by doing it all in one tool and presenting these findings contextually, productivity can be much better. Managing vulnerabilities. If there's any security professionals here on the call, I'm sure this is a task that you might detest. What happens if you uncover a huge number of vulnerabilities at the end of a given software development lifecycle? Nobody wants to go back to their product manager or to their stakeholders in the executive and explain that their timelines are blown because late in their development process, they've uncovered a number of vulnerabilities. So what if you had the ability to empower developers to deal with each one of these at the point where they're introduced? Let's talk about how GitLab can help. We call this shifting left with GitLab. So here's a revised pictorial that helps you understand when I say finding vulnerabilities before the code is merged. Just as before, we have a GitLab repository here where the developer may be making a change. Maybe it's a bug fix or a new feature. They'll push that commit to the repository, which will trigger GitLab's CI engine. But at this stage, just like before, they'll get their test results for things like unit testing or otherwise. They can also benefit from a review app where an ephemeral copy of their application is deployed and the code ends up running as it would in a test environment. And from here, GitLab security testing for things like dynamic application security testing can run. Developers, just as before, can then create or dismiss issues as these findings are found. The merge request is really the point of coalescence, the point of collaboration, as we like to call it at GitLab. So you might be familiar with merge request or pull request. This is where the developers, compliance auditors, security professionals, and other stakeholders can collaborate on the code changes at hand. Security is also empowered to take part in this process. Not only can they engage within the merge request itself and have a dialogue about the potential findings, but they can also at any time understand on a per project or per group level the findings within different code posted in GitLab. From there, they can dismiss irrelevant findings. They can create issues to perhaps prompt remediation of that vulnerability at a later point. And all of this means that you can deploy more consistently and more frequently. Here's kind of another spin on the same idea. This picture illustrates, I hope, a familiar branching strategy. We call this GitLab Flow. But here you've got your default branch, main or master. And typically everything starts with an issue. That's the way we think about it at GitLab. So if the issue says, hey, here's a bug I want fixed, or here's a new feature I'm proposing, from there, a developer can create a merge request. Then they can start pushing code changes into a feature branch. With each and every change, GitLab's CI pipelines run. But critically here, what we're showing is that security scans can be integrated as part of that pipeline, and we're moving security testing as close as possible to the developer. As I mentioned before, developers and other stakeholders will benefit from a review app, which is an ephemeral copy of the running code. And as I mentioned before, the merge request being that point of collaboration facilitates discussion, not just for code reviews, but also security. So security engineers and professionals can have that agency and dialogue directly with developers as these code changes are being tested and considered and before they come into a production environment. There's also the ability to insert approvals. So using tools like GitLab's code owners or merge request approvers, you can set up a policy whereby designated individuals have the right to approve or deny changes before they end up merged into your mainline branch. Once they're merged, your deployment pipeline can run, your environments can be updated, and you can additionally run security scans on those production environments. To give you an overview of the vast array of different scanning and security tools that makes available to you, we always like to throw this slide up here. I won't read this ad nauseum, but I will share that there's technologies like SAST, DAST, and even Fuzz Testing, part and parcel and included with GitLab. Many of these are actually available as part of our core offerings, so the free open source version of GitLab. But the contextual presentation of these findings is really where the value add of GitLab comes in. So what does this look like in practice? We thought it was appropriate to show you an example of a pipeline. Hopefully this is, again, if you've got experience with our product, this should be a familiar view. You can see here the build stage. Your code is going to get built and packaged up in a way that is potentially deployable. And then you might be familiar with seeing a test stage with a number of parallel jobs that are testing things like code quality. And in this case, we've included things like container scanning, dependency scanning, license management, and SAST, in addition to the other tests that the developers may have specified. After those tests have passed successfully, the app can then be deployed to an ephemeral, a short-lived environment as a review application. And from there, with every pipeline, you can run a dynamic scan of the application at runtime. You can also run browser performance testing. All of this means that results can be shown to the developer while they're considering this change and before it makes it into mainline branch. This helps you scale because it empowers developers to address security findings before they merge the code, and it also highlights to potential approvals any security findings that may be potentially introduced into your code base. This right here is a picture of a merge request with what we call our security scanning and license compliance widgets. So again, should be a familiar screen. We're talking about a feature branch here that the developer was working on, getting merged potentially into master. You can go here to review the code changes themselves, the number of pipelines run against those commits, and a diff against the files as relevant. But additionally here, the contextual value is that this security scanning widget here is shown. So as part of this merge request, the developer can see that a total of 28 different vulnerabilities were discovered as part of this new feature branch, 4 of which have already been dismissed, but 24 are still in the new state. This empowers developers or other folks to review these and before approving or merging this merge request, action them appropriately. Likewise with license compliance. This particular merge request screenshot shows the situation where 2 new, perhaps open source licenses are being brought into the project by this change. You can opt to then go into the manage licenses section of the tool to adjust perhaps a policy, view the full report of the findings and understand which licenses are there, or expand the widget to drill down into it. And let's talk about that drill down capability. So again, we're still within the context of that very same merge request here, but the security scanning widget has been expanded. And we can see here that this particular example shows a number of different medium severity findings detected by the SAST scan that ran as part of the merge request. We're integrating best practices into this merge request here. We're automating the security workflows to help provide teams an adaptable process and help them execute more quickly. Beyond the drill down capability, if you were to click directly into one of those findings, you'll be presented with what we call a vulnerability page. This page is essentially a card that describes the vulnerability itself and helps give the developer or security professional more information about how to address this vulnerability. So in this case, there's a finding here, a serialization vulnerability related to this logback core module that this particular project included as part of its pom.xml file. This is a critical severity bug, so definitely something that you'd want to take some time to understand. Dependency scanning here was the scanner that picked this up. It uses GitLab's proprietary gymnasium scanning technology. So in addition to the name and maybe some light details as to what this vulnerability is, the page here will also show you the file and sometimes the line that the vulnerability was discovered within. And it typically will also link out to a number of different details about the bug. So here we've got a link to the CVE database, as well as the page for the logback core module itself. We also present a prospective solution, right? So in this case, the suggestion to the developer is, hey, this is a known vulnerable version of the logback core module, upgrade to the latest version. From this page itself, developers or security professionals can dismiss the vulnerability, or they can create an issue prompting this vulnerability to be addressed in perhaps a future or separate stream of work. Alternatively, developers can also fix those vulnerabilities directly within the merge request itself. Beyond some of those details, in select contexts, including dependency scanning and container scanning, we'll also present the opportunity for automatic remediation. So in this case, there's a finding here as part of this vulnerability page where this auto remediation demo had picked up the fact that an older version of the muscle library was being included, which is affected by CVE 2019-14-697. While this is a high severity bug that or vulnerability that likely requires addressing, the solution here is very specific and prescriptive. We need to upgrade from the R3 to the R4 version of the 1.1.18 version of muscle. And if the developer, Adam here, wanted to resolve this immediately, we offer a resolve with merge request button that will automatically create an MR with the necessary change to update that version of muscle on their behalf. Let's talk a bit more about how GitLab can help security teams additionally understand and have better visibility into these types of vulnerabilities. So it's great that we're providing developers agency, but if you're part of a security team, you may not want to completely relinquish yourself of the duties that your team is accountable for. So how do you get better visibility into the security risk and the risk footprint of your projects or your groups? GitLab offers a functionality we call the security dashboard. And this provides the ability for you to quickly understand at a glance the risk your projects or your groups have. So in this case, the security dashboard here shows us a roll-up of the number of vulnerabilities that have been found. You can change this from a 30, 60, and 90-day basis, and some burn down charts as to the number of critical, high, medium, or low vulnerabilities present. Additionally, for all the projects present within this dashboard view, so this is for a specific group, you can see a graded basis. So there's 2 projects that would receive a grade of F, so they likely have a number of critical vulnerabilities that are open and unaddressed, all the way through to A, 2 projects with likely no findings open. You can drill down, so if you were to expand one of those findings, you can understand here and click into the projects that have a number of high, medium, and low, or critical vulnerabilities open. This helps you as a security professional understand and manage your risk across your entire organization. The group security dashboard provides an overall view of the vulns of all projects within a group and subgroups. You can drill down, as I was mentioned before, from the security dashboard view to understand the affected projects, the files, and get some additional metadata to help you analyze the risk. So here we can see for this particular group, again, a count of critical, high, medium, low, or info level, or perhaps unknown or uncategorized findings. And we can see for each of those findings, which file it occurs in and which scanner surfaced it. Let's talk about the per project level. Similarly, this provides a greater level of detail with additional burn down charts for you to understand on a project by project basis the most recent security scan result on your mainline branch, as well as jump into any vulnerability pages and address those. Each and every time the mainline branch is updated, security scans are run as part of a separate GitLab pipeline. And you can additionally specify a scheduled security pipeline run to ensure that this view is up to date and has the most recent information about that given project. From the dashboard, if you were to dive into this, you can jump into a vulnerability page just the same way I showed before. And here, this click through shows us how you can adjust the status of a given vulnerability. So in this case, perhaps this is a critical dependency. I'm likely not to dismiss it. If I'm more of like a security assurance persona, and I want to make sure that I'm rating the findings and perhaps giving teams more actionable feedback as to what is actionable and what is priority versus what is not, I can set this as a confirm, meaning a human being, myself, has reviewed this, and I'm of the belief that this is a positive vulnerability, and we should do something to address it. There's several different statuses. Detected, that's the default state for any newly discovered vulnerability. Confirmed, as I mentioned, I'm a human, I've reviewed it, I'm confirming it's real, we should action it. Alternatively, I can dismiss it. So if I've seen this vulnerability and reviewed it, but don't believe that it requires action, I can choose to dismiss it. And then resolved. So when this vulnerability itself has been removed from the code base, the status of this vuln will be changed to resolve. From here, you've got the optionality to create an issue. So if you wanted to assign a specific DRI, or you wanted to have a conversation with different stakeholders about what should be done to address a given vulnerability, the issue is the right place to do that. I'll jump into details and resources, and then we'll likely be on to Q&A. So I think there's about a 10-minute warning before we get into Q&A, so submit those questions now. Like that high-level slide I showed before, I do want to spend a bit of time talking about what each type of scan is. So GitLab offers static application security testing. These scanners are actually available as part of our core product, but if you want the merge request and the security dashboard functionality, that is ultimate level functionality. And in my opinion, that's where the real value add of GitLab comes in. So with SAST, what we're doing here is we're analyzing the code itself for known vulnerabilities. We support a huge variety of languages, anywhere from Microsoft's .NET all the way down to TypeScript here. What this does is it checks with a known database of vulnerabilities, compares the found vulnerabilities of your source branch, and it'll contextually show those potentially newly introduced vulnerabilities as part of that feature branch's merge request before they end up in mainline branch. Container scanning. So GitLab previously used Aqua's Trivia engine to perform static analysis on Docker images to look for known vulnerabilities within your application's environment. It analyzes the Docker image's contents against publicly published vulnerability databases, and again, shows these inline in the merge request itself. We also offer dynamic application security testing, formerly based on OWASP's Z-attack proxy. And what this does is it analyzes your running web application for known runtime vulnerabilities. So what this will do is it'll run against a review app, which is a running copy, short-lived, of your application, perhaps deployed to a Kubernetes cluster, but there's some optionality in how review apps work. Out of scope for today's conversation, I'll say. You can optionally provide HTTP credentials to test private areas of your application. So that's something that we've added on top of or around the Z-attack proxy. Likewise, with every other type of scanner, these vulnerabilities can also be shown inline as part of a merge request widget. So they're presented to the developer where they're working. Next, I wanted to touch on license compliance. What license compliance is it can help your organization or team search for and detect different dependencies that your project may be bringing in that potentially have undesirable types of licenses. You can define a policy to allow or deny list select types of licenses that you don't wish to be included as part of your code base. And it also offers manual approval or deny. Let's touch on dependency scanning next. So what this can do is help scan for your project's dependencies and analyze them against known vulnerabilities. So that muscle example I talked through previously, that's a great example of dependency scanning. So we support Java, JavaScript, PHP, Python, Ruby, Scala, and Go languages when it comes to dependency scanning. This is a fairly new bit of functionality that I quite like, our software bill of materials. Because software these days is typically based on a wide variety of open source components, and sometimes proprietary components as well, the bill of materials helps present a view of the information and give you, as well as your compliance professionals, additional information so that you can understand what different piece parts comprise your applications. The bill of materials is really built upon a combination of what dependency scanning and license compliance provide, and it gives you a singular view of the different licenses and dependencies your projects are pulling in. Next, let's talk about fuzz testing. So beyond DAST, the ability to detect unexpected behaviors as a part of unexpected inputs of a runtime application, fuzz testing can help you detect unexpected defects and weaknesses by inserting malformed inputs into your application. This not only can help you with security concerns, but it can also help you, understand the stability and reliability of your application, which can sometimes lead to exploitable vulns. It can also help confirm reproducibility by minimizing false positives and identify root cause analysis. Likewise, with our other scanners, the key message here is that we can help you shift left by adding coverage-guided fuzz testing as well as API fuzz testing from the very second that you're changing your code. That's a wrap on the material I had presented. We've got some other auxiliary material if folks are curious to get into compliance a little bit more, but I think let's pause and take some time for Q&A. I've seen a couple of questions come through chat, and I'll ask Chris, Sam, or Sean if you've got ones you feel are particularly appropriate for live discussion. We've got the benefit of almost 30 minutes here to discuss.
Sure. There's one from Denise Zebro. And he asked, is it possible to auto-merge the vulnerabilities without going through all the issues one by one, or set the level of a vulnerability level to be merged?
Oh, that's a great question. So in the case of something like an auto remediation for dependency scanning or container scanning, could you set up a policy to just auto remediate when those findings happen? To my knowledge, that's not native functionality in GitLab, but it certainly would be possible via our APIs. So while it might take a little bit of engineering, a little bit of glue code, you could likely do that on a regular basis by polling the APIs. We expose the results of our scanners via an API. I'd have to take it away to understand for sure if we could offer an API that would trigger that auto remediation. I think at very best, you might be able to automatically get to that merge request level. Beyond that, I would say where I am Denise's shoes, I'd probably want a human being to review those merge requests before they get pushed to mainline branch. So there's piece parts that you could automate, but I think before I would fully end-to-end say, start changing the dependencies within my projects and merging them to mainline. I'd want to build a queue that a human being reviewed. Great question. Thanks for the question.
And Jamie, before we jump to the next one, I'm just going to go ahead and pop open a feedback poll. If the folks on the line want to take just a minute, there's just a couple quick questions there. Let us know how we did today, and yeah, we're looking forward to doing more of these. So thank you.
Thanks, Joe, and appreciate the folks that are offering feedback. We really appreciate that. So while we let those results trickle in, I see another question that Chris Guittard had captured from an attendee, and they provided a sample error from the license finder. So our license scanning job had run and provided an output that said, quote, no active or installed package managers are found for the project. So without reviewing, that particular example personally, the way that reads to me is it's likely the project isn't a language that our license scanning supports, and or it's possible that the dependencies file, like your package file, like a package.json in the case of a Node.js project, or a pom.xml in the case of a Maven project, isn't being found by the scanner itself. Well, in the case of, so I'm thinking more about dependency scanning. So in the case of license scanning, I believe it's looking for a license.md or a license.txt. And if it's not able to find, no, I take that back. I'll jump back to my earlier answer, which is really that license scanning, it's going to look at all of your different dependencies and look at the licenses within those. So it'll depend upon having that either a package.json or another very similar, depending on your language specification of the dependencies of the project. Hopefully that helped answer the question. And to the attendee that asked, if it didn't, feel free to drop a follow-up. Well, we'll give it another 30 seconds in case there's any last-minute questions. And if not, we'll always have to give folks a little bit of extra time back in their day. Keep it short and sweet and to the point.
There's a question from the previous question about license manager. It's on a mono repo. Does that make a difference?
It may. So it's conceivable that the scanning may need a little bit of additional configuration. And while I don't have a ton of personal experience digging through that in a mono repo context, it's very possible. Go in Angular. Okay. If you want a little more help with that, I would encourage you to either open a support case. If you go to support.gitlab.com, you can always ask a question there as a subscriber or paying customer at GitLab. And failing that, feel free to share with us an email. We're happy to reach out to you and dig into it ourselves a little bit more. Well, I think that concludes all the Q&A. To the attendees that spent time with us today, thank you very much for your time and attention. we look forward to seeing you on one of our additional or future webinars as well. And I'll turn it back to Taylor for a brief close.
Yeah, that does it for me. Thanks, everybody. Appreciate you joining. And like I said, we will send out the follow-up email with this recording linked, so you have access to that in the future. And hope you have a good rest of your day.
Thanks all.
Bye, everybody.